if the school is a community, who do you interact with here? Who is your population? All right, so your population is students. Would I actually probably divide you guys down even further than that?
Probably our class.
All right, so you have populations of freshmen, sophomores, juniors, and seniors. Populations. Do you interact with others within your population?
Yes.
Do you interact between populations?
Yeah.
Is that the only part of your community with which you interact?
No.
What else do you interact with here?
Teachers.
All right, teachers.
Janitorial staff.
What?
Janitorial staff.
Janitorial staff?
Bacteria
Maintenance?
living on the ground.
What?
Bacteria living on
Good one.
Are you like
So-
rolling on the ground or something?
We, my friends, we're listing all these living parts of our community. Are there other ways that we interact?
With the air.
You have your iPads. In the hallway, every 4th hour, I'm out there with this, right? And then I go to art class 5th hour, and I still have this. What am I responding to in my community? Temperature, right? How about as a community when we head into a pep rally, how do you respond?
We're all cheerful.
You're cheerful.
You respond loudly.
You respond in volume, right? There's a volume that you respond to, so you recognize the cues in your environment and you respond accordingly. How about when we go as a community over to church?
You're respectful.
You change your demeanor to reflect respect, temperature control, right? We have to interact with that part. You agree that sometimes we get to church, it's hot in church, but it's cold here. You respond to those things. They're all non-living things, but is it pretty much a guarantee that it's probably going to be fairly cold in this particular classroom? Can you think of the last time it wasn't cold in this particular classroom?
First day of
It's
school.
like not cold in here.
I was like,
I always think it's freezing in this room. My fingers are always blue though. And they're not painted that way. So they're just fingernails really cold pretty permanently. It also explains why I walk around with a blanket. Just a scarf. All the time. You respond to that. You respond in volume. Available nutrients. Do you respond in that way to what's available in the lunchroom? After school, there's always a line outside the Falcon Feeder, right? There's stickers on these. I wanna peel apart this. Should probably put that sticker back on. So, there are living parts of a community and there are non-living parts of a community, and you interact with both. Accurate? So, for ecological purposes, it's no different. There are living parts and there are non-living parts of any community. The non-living parts are what we call abiotic. The non-living parts of a community are abiotic, and the living parts are biotic. And an organism living within a community must respond to both. They respond and interact with both living things and non-living things. Respond to both living and non-living things. And we'll start with the non-living because non-living, well, that's pretty easy. Well, I think it's easy. What kinds of things could we say are abiotic factors in an environment? Non-living factors. Weather. Furniture for you guys, right? It's physical things. Stub your toe. What about climate? Is that the same as weather?
No, not necessarily.
Do you think that's an abiotic part of the environment? You betcha.
Would time be one?
Time in the measure it sense, or time is in the sense of like the sun going up and down?
Like time as like trying to like maintain time.
So you guys live on deadlines.
Yeah.
So that's a part of the interaction in which you operate. In the ecological sense, do animals have deadlines necessarily?
Well,
Kinda, right? Like they operate seasonally, don't they? So we have some response to changes in hours of daylight. I mean, if you're a nocturnal animal, does a change in the hours of daylight matter to you? Probably. So it's a response to the environment for when you're going to have young. It's usually, typically, if you live in a place with winter, probably a bad idea to have babies, now. Why would it be a bad idea to have babies now? Yeah, it's kind of a rough time of year, right? I mean, there's not a whole lot of available food. And more babies means more food. Winter doesn't necessarily always mean food. There are some animals who do it. There are some animals that will just gestate over the course of winter, which also to me, like, that seems like a bad choice, but whatever. What about...
Like land formation, for people it might be like roads or traffic, but for animals it would be like the rocks and that.
Rocks, sand. I mean, if you're a mountain goat, you probably should be fairly adept at being on something rocky and precipitous. Versus, like, I don't know, something who doesn't dwell well on a mountain.
fish.
Not a mountain goat.
Fish don't do that.
Fish don't do well on mountains, particularly, I suppose. Other things that may be a concern, the pH of your environment. If you're aquatic, that's a big deal. And the salinity, or the amount of salt in your environment, if you're aquatic, also a big deal.
Is humidity part of weather?
Humidity I would put with climate, yeah. So whether you're arid or not, whether you're mesic, whether you're swampy, so humidity and the amount of available water is a big deal. That's why droughts are a problem in areas that are typically, predictively according to climate, should be moist. If you have a drought, that's a problem. Oh, Quinn's next hour, I said moist, and it annoys him. Sorry for those of you in here who it annoys, but now you all know the super secret. Don't tell him I told you. These are all abiotic, non-living factors of the environment. Some organisms are more or less successful at living in a range of conditions. So these abiotic factors lead us to talk about what we call tolerances. There are two general kinds of organisms. They're what we call generalists, and there's what we call specialists. The y-axis going up is what we would call success. So how well one lives, how healthy one is, how many offspring one has. That's how we measure success biologically, is lifespan and number of offspring. On the x-axis, we have range of conditions. On the x-axis, we have a range of conditions. Generalists are very, very good at surviving in a very broad range of conditions. So their graph would look like this. They're excellent across all sorts of ranges. And you can make these conditions whatever you want. You can make it pH if it's aquatic. A generalist could live at both low and high pHs. You could make it salinity. A generalist could live in very low levels of salt and very high levels of salt. You could make it temperature. Any condition, any abiotic condition you wanted, you could put on that x-axis. Success. Biologically, success is typically measured by number of offspring and lifespan. Specialists, on the other hand, specialists have a very narrow window in which they are successful. It's a tiny window, itty bitty. That's sometimes good and sometimes bad. If your environment is perfectly suited to that, like you have that range of conditions at all times, no need for you to go anywhere, life is good, you will survive. Sometimes being a specialist is bad. Whether you are a generalist or a specialist, that predicts what environment you can live in. So that will tell you what environment you can live in. We'll talk about a couple of generalists and specialists so we get an idea. So a niche has all of the necessary abiotic factors to support that particular organism. God bless you. A fundamental niche is where they could live, all of the potential locations that they could live. And a realized niche is where they do live. Additive exclusion principle. And what he's saying here is there's actually a limited number of fundamental niches. There's only so many, and you're going to have to compete. Now, who did the nutches compete with?
Each other?
Yeah, other nutches. You mean you have to compete with your own? Survival isn't just like, oh, we're a happy community, let me help you, you're one of my own. We have to watch our back from our own species. So there's competition within a species, not to mention the fact there's competition between species. That species do within the species, right? They also interact with other species. This is the part you know well. Take a moment. What kinds of interactions, my friends, do you have between species?
They can transmit diseases sometimes.
All right, so they are disease vectors.
They can like physically contact with each other.
So they can actually, is it always holding hands contact? Is it sometimes like a rip your face off contact? So they could be like fighting. It could be predatory. They could compete.
Bodily fluids. Does that count?
In as much as disease vectors, yeah. They could reproduce with each other. That's interacting, well, within a species, right? So basically, we have 3 different ways of interaction between different species, right? It could be, let's just list it this way. This is what we call a pairwise interaction table, by the way. And I should also tell you, SPS is the biological abbreviation for the word species. Commonly accepted. So we could have an interaction that's beneficial for both species, right? Doesn't always have to be bad. Sometimes it can be good. It could be a win-win. Examples of win-win. I don't know about you, but the number of times I've ever been to the zoo, I have never met a rhinoceros who is able to articulate his arm to scratch its own back. Accurate? Never seen one of those. Rhinoceri have like Barbie and Ken joints. They only go like so far, and they don't go like that, or Ken's leg or Barbie's leg rips off. Agreed? You guys are like, what are you talking about? Okay, G.I. Joe joints. They only go so far. Not like Stretch Armstrong. Does that mean that a rhinoceros will never get an itch on its back? So what do?
It has the little birdie come and like scratch.
There's a reason that in just about every cartoon of a rhinoceros you've ever seen, there's a bird sitting on its back. That's because in real life, a bird will sit on the back of a rhinoceros, and the rhinoceros lets it stay there because that bird, it scratches that itch between his shoulder he just can't reach. And it's a win for the bird because it turns out the rhinoceros is itching because he's covered in bugs. So the bird eats the bugs. The bird gets lunch, catered, right? It doesn't have to go very far, it's just right there. Bird gets lunch, lobster gets scratched, everyone's happy. That kind of lobster gets scratched, rhinoceros gets scratched. I don't think you have to scratch, I wouldn't scratch a lobster.
Diseases that way.
You don't really get that many diseases, but they get violently angry. It turns out angry lobsters unfurl their tails, and when they unfurl their tail, they release a chemical that decomposes their meat, and it makes